So OSPF, Open Shortest Path First. This is not an ordinary protocol, I tell you. This is an extraordinary protocol. Open Shortest Path First. The reason why I call it as extraordinary is for various advanced technology. Only if you have OSPF, you can have them. Example, if you would like to do traffic engineering with a protocol called RSVP and PLS, you need a link state routing protocol. Yes, OSPF is a link state routing protocol. It is a link state routing protocol. Shortest path first is an algorithm which is used by this routing protocol. And the shortest path first is an open standard protocol. Using this open standard shortest path first, the routing protocol OSPF is designed. So this is also an open standard protocol. Open standard. Open means what? Ready to connect. Open standard. Anyone can use it. Ready to use. Open. We all know open meaning. If the restaurant just got the board open, we can go consume the food. So this protocol is open to communicate with any routing device. It can be Cisco or non-Cisco. Doesn't matter. It is open. Every routing appliance will have this protocol for sure. So this is a very famous, popular, well-known protocol. Well-known routing protocol, OSPF. Open Shortest Path First. And it is a link state routing protocol. We all know every protocol has got metric. This protocol has got a metric called cost. This cost is by default auto-calculated. Based on what? Based on bandwidth. The cost is auto-calculated, meaning what? Cost is determined dynamically based on the bandwidth on the link. More bandwidth, less cost. You see? More bandwidth, less cost. This itself should say this protocol is very special protocol. When you go and buy a diamond, you give more money to buy small stone. Once in my life, I got a chance to buy diamond. It's just 2.5 lakh rupee. I thought, wow, I'm having 2.5 lakh and I'm in Qatar. So in Qatar, diamond is very good. But he gave me one small dot of diamond. What is this? I gave this much money, he gave me this small dot. Small dot of diamond. I cannot buy one like what Jayalalitha used to wear, the diamond earring. I used to admire. Wow, this big she's having. I spent 2.5 lakh. They gave me one small dot. This woman is carrying on both her left and right ears this big diamond. Wow. I used to admire when she was there. I bought the diamond for my first child. Like diamond, more bandwidth you have, OSPF will say, I'll prefer this path because the cost is going to be low. More bandwidth, less cost. I'll give you another example. If you're driving a bike in a rush road, narrow road, market road, cost will be high. Why? Because bandwidth is low. You used to put brake because I also told it is narrow and market road. You'll put a lot of brakes and then you'll apply accelerator, again put brake, accelerator. Cost is going to be high when the bandwidth is low. When the bandwidth is low, cost is going to be high. Inverse proportional. Inversely, it is proportional. Now, what if I want to give a cost? Yes, you can give it. Then what will happen to the auto-calculated cost? It won't be considered. So I repeat. Usually I focus these things in CCNP, but I just want to tell now also once. Cost is calculated automatically, which most of the people will rely upon the auto cost. But the cost can also be configured over the ports on the interfaces. Cost can be calculated. Sorry, cost can be configured. If you will configure cost per port, the automatic calculation of cost will not happen on that particular port. For example, this A is trying to go via this path and this path to reach this network. Let's say in this link you have 30,000 network. Now A is trying to go to 30 via both A, B direction as well as C direction. The reason is automatically cost calculated is showing equal cost on both paths. The reason is you have same bandwidth. This is also fast Ethernet. This is also fast Ethernet. So the bandwidth is equal. When the bandwidth is equal, cost is same in both the paths, which you don't like. You don't like both the paths to be used. Maybe you want this path to be the primary and this to be the backup. So what we do, we can go and configure cost manually 10 on this port and this port. When you allow it to calculate by itself, it shows same cost on both the paths. But you don't like two paths for this destination. You want only via B to reach 30. So what you can do is you can increase the cost manually and make this path bad compared to the other one. The other one, the cost is just 1. This is 10. Yeah. So we configure cost manually to do this type of manual policy based path selection. So can we configure cost manually? Answer is yes, which many people don't know. So open shortest path first. Cost is auto calculated, which many people rely upon. Some people don't even know that it can be configured manually. So they fully just leave it to automatic calculation. Now, like EIGRP, this can also support up to 4 no, equal cost load balancing. EIGRP also can support 4 equal cost load balancing by default. OSPF can also support equal cost load balancing. What is equal cost load balancing? We just saw. If the cost is same, then both the paths will be used. If I have more paths, here also one. All 3 can be used. What if I have 4 paths? All 4. If I have 5th path, one will be ignored. Which one? Anyone? So when the cost is same for a destination across multiple paths, up to 4 can be used by all protocol, not only OSPF. Only EIGRP can do unequal cost load balancing. I told you no other protocol can do. Will OSPF support unequal cost? No. Let's say here the cost is 2. Here the cost is 3. EIGRP can use, but OSPF can't. EIGRP will not use it by default. You have to do a lot of configuration that we will be learning when we come to CCNP. But what I'm trying to say here is you can calculate, sorry, you can only change this cost to 2 manually to make these and this to be used. If you want all 3 to be used, then make all same cost. OSPF supports only equal cost load balancing. Don't forget, equal cost load balancing only. Up to 4. Sometimes they may ask you a question, can you increase the number 4 to number 6, 7? Yeah, you can. There's a command called max path. You can configure and increase the number of equal cost. Again, it is only equal cost. You can increase. The answer is yes, you can increase. Next. This protocol also maintains neighbor by sending hello packets. To discover neighbor, it uses hello packet. Even after forming neighbor, it will send the hello packet periodically to maintain the neighbor. Same like EIGRP. EIGRP also sends the hello packet to discover new neighbor. And once the neighbor is discovered, it is going to keep sending the hello packet. In EIGRP, it is every 5 seconds. In OSPF, hello packets are sent every 10 seconds. If it is LAN. If it is WAN, it is 30 seconds. And the dead time is 40 seconds and 120 seconds. You see? So, there is different timer for LAN and WAN, but focus on this one. Not too many people know about this. Maybe those who Google for interview and learn some question there, they may find this question. But people who learn things practically, they may not be knowing about this. The reason is we don't have much OSPF and WAN environment. We have BGP. WAN means a lot of things actually. You see, when you have a serial link with frame relay. What? Frame relay. Yeah, you heard me right. There is a technology. There was. No, there was only. Hmm. Frame relay was one technology. That is what WAN is. In such environment, only this timer. That is why I said this is not much popular. It should not be asked in the interview because the frame relay technology and all gone. And when I started, it was not. It was almost going out from the industry. In 2006-7, it was slowly going out. Now it is nowhere. When I was teaching in 2000 in Tata Teleservice, Hyderabad, in 2013, they said they have one frame relay segment in their office, the TTSL. But I don't know whether they still have it. It's very old technology, costly as well. So maybe Indian interviews, you can't judge. If you know it is good. In LAN it is 10 and 40. In WAN it is 30 and 120. Always the dead time is 4 times of hello. You see, 4 times of 30 is 120. 4 times of hello is 40. 4 times of 10 is 40. Now, hello time should match with the neighbor. I repeat, the timer should match with 2 routers to form neighbor. Not only timer, we also have something called area ID. Area ID also should match So timer should match, area ID should match. What else? Subnet mask should match. You see, on one side, you gave 10.1.1.1/24. On the other side, you say 10.1.1.2, but accidentally you put 16. Area is same, timer is same, but the neighbor won't come because of the subnet mask. Because of the subnet mask, the neighbor will not come. Subnet mask also should match. These are all nice questions to be asked in interview. What all must match in order to form neighbor? You see, if you know this, it will be easy for you to troubleshoot. நெய்பர் வரல நெய்பர் வரல நெய்பர் வரல பேசிக்கிட்டே இருக்குது. நான் எல்லாம் கரெக்டாக தான் போட்டிருக்கிறேன், நெய்பர் வரல. என்னமோ சிஸ்கோ ரவுட்டர் தான் வந்து சரியில்லைங்கிற மாதிரியும், இத்தனை வருஷமா இருக்கிற அந்த வெண்டர் வந்து தப்பு பண்ணிட்டான்ற மாதிரியும் திருப்பி திருப்பி சொல்லுப்பா. எல்லாம் கரெக்டாக தான் போட்டிருக்கிறேன், ஆனா நெய்பர் வரல பாரு. பக்கத்துல பார்த்துட்டு இருக்கிறவனுக்கு அது கூட தெரியாது சுத்தமா. அவன் ஆமா ஆமா இல்ல, ஏன்னா அப்பதானே நீங்க அவனுக்கு தெரியுதுன்னு ஏத்துப்பீங்க. ஆமா ஆமா இல்ல, அவன் ஆமாம் போடுறதுனால அவனை நம்பிடாதீங்க. உங்களுக்கே பெட்டரா தெரியும் அவனை விட, ஏன்னா நீங்க ஏன் ஸ்டூடெண்ட். உங்களை நம்புங்க. ஏரியா ஐடி மஸ்ட் மேட்ச், சப்நெட் மாஸ்க் ஷுட் மேட்ச், டெட் டைமர் ஷுட் மேட்ch. Of course, hello timer will be 10 if dead timer is 40. Simply, I can say timer should match. Okay. Now, before I talk about area, I want to talk about what makes this OSPF to be called as a link state routing protocol. Every router will tell to others about the links which they got, the IP address and the subnet mask on the link, cost, if you calculate that cost, if not, auto cost. So all these informations will be advertised as a advertisement called LSA. Every router will start advertising link state advertisements to their neighbor. I repeat, neighbor, which means what? Already hello packet went. They both accepted each other as neighbor. And now they are trying to share the routes now. Share the link state information, not the routing table. EIGRP advertises the routing table with a metric same like RIP. That is why I don't want to say EIGRP is a hybrid protocol. Why? EIGRP has got no identity like OSPF. OSPF, you see, it is not advertising the routing table. It is advertising the links. Every router is advertising that I have this fast Ethernet 00, IP address is 30.0.0.1, subnet mask is /16, and the cost is 1, like that. And this makes the other router to know about the links of this router. Like this, every router, they start sending what links and the status of the links that makes the routers to know the topology. Assume you are these 3 routers. You are one of the 3 router. Assume. சிறிது கற்பனை செய்து பாருங்கள். நீங்கள் இந்த ரவுட்டரில் ஒருவர். இருட்டு அறை. It's a dark room. And you really don't know who is in that room. Now, someone is throwing a small stone towards the left direction where you are sitting. Now you understand to your right someone is sitting because to his left the stone was coming. It was hitting your right. So you understood that there is a person. After some time, one stone is coming and falling on your left also. You understood there is also one guy in the left. But when you take both the stone and the sea, it is not a stone, it is a nameplate. You can just read it like a blind people reading the braille. When you read, it is written your friend's name. Now you understand your friend is the one who is connecting to your left and right. Like this. So when you throw stone, you don't simply throw stone, you say, hey, நீ யாருன்னு நான் கண்டுபிடிச்சிட்டேன். உன் பேர் அதுதானே? You say his name and you throw the stone on this side and this side. Now he also understand we are connected like this and it is you the one who is sitting opposite. Like this, LSA is like a stone. Every router throws and all router will discover who is connected to who. For example, if C is throwing to B, B will know about C and B will throw to A with C also in it. With C information and B information will go to A. A already know I am connected to C. Now it also knows that C is connected to B and B is connected back to me. So we are connected in a circle. They discover the topology and the location of all destinations using this advertisement called LSA, link state advertisement. Link state advertisements makes this discovery, not the routing table. See, I said in the beginning itself, it's a special protocol. If you go to a restaurant, they'll give a big menu. And you pick one which you like to eat. Like I had a shawarma this evening while coming. Now, in your home, that won't work. குடுக்கறத சாப்பிட்டு கிளம்புப்பா அப்படின்னு சொல்லுவாங்க வீட்டுல. In house, you cannot have a list of menu card, food menu, and say, give me this, give me that. கிளம்பு கிளம்பு காத்து வரட்டும் அப்படின்ட்டு வாங்க அப்புறம். So, why I'm saying this, you like a restaurant, right? Because according to your mood, you can change your food that you want. அப்படி நம்பிதான் போய் அவன் எந்த கையில் அதை செஞ்சானோ கழுவிட்டு செஞ்சானோ இல்லையோ அதை சாப்பிட்டு வியாதி வர வச்சுக்கிறோம். போயிடாதீங்க நான் சொல்றேன்ட்டு. So, where am I? RIP and EIGRP is like our house. இதான் இருக்குது வீட்டில், இதை சாப்பிடுங்க. We'll eat. We trust. We don't want to go and check whether mundri is there or not. முந்திரி எல்லாம் காலி ஆயிடுச்சுங்க, முந்திரி ஃப்ரை எல்லாம் கேட்காதீங்க, வெறும் டீயை குடிங்க போதும் அப்படின்னா நம்பிடுவோம் பாருங்க. போய் வெரிஃபை பண்றது இல்லை ஸ்டோர் ரூம்ல முந்திரி இருக்குதா இல்லையான்னு. That is how RIP and EIGRP works. If a router is advertising a network with a hop count or a composite value, the receiving router will simply believe it and take it. There is no mechanism to go verify. But in OSPF, that is not the case. Every router advertises the complete link state information. இதுதான்ப்பா இருக்குது, தான் மெனு பார்த்துக்கோ, நீ முடிவு பண்ணிக்கோ எந்த பாதை உனக்கு சிறந்ததோ அதை நீயே முடிவு பண்ணிக்கோ. இதெல்லாம் கனெக்ட் ஆயிருக்குது. These routers are connected to these other routers through these links, and this is the IP, this is the mask, this is the cost. Boom. You decide what is best for you and put it into the routing table. I am giving you the map. You decide which path is best for you. See, they all form a map, a common map after sending LSAs. After these routers share LSAs, every router will have a common, identical map. We call that map as link state database. Link state database. Link state database. Every router has got a link state database. On that link state database, SPF algorithm. What is SPF stands for? இன்னும் ஒரு முறை சொல்லுங்க. Correct. வேற யாராவது ஒரு முறை சொல்லுங்க பார்க்கலாம். What is SPF stands for? மூர்த்தி வேண்டாம், சரவணா சொல்லுங்க. What is SPF? நல்ல வேலை நான் தப்பிச்சேன். எனக்கு பயம் வந்துச்சு நீங்க அமைதியாவே இருக்கிறதுனால. நான் நடத்துறதுல இவருக்கு புரியுதா இல்லையா, ஓவரா இங்கிலீஷ்ல பீட்டர் விடுறோமோ அப்படின்னு பயம் வந்துச்சு. புரியலையா நான் பேசுறது? சரி. So this SPF algorithm will be running on top of this LSDB on each router, and this SPF algorithm on each router will decide their own best path, and that path will be recommended to the routing table, and it will be placed inside the routing table. So you see what I'm trying to say here is, this is not taking the routing table given by other router. It is just collecting the link state information from other routers and deciding the best path by itself. If I need to give another example, it is like this. You're going to a country which I don't want to go, called Libya. Because for local Libyans itself, there is no safety. They kidnap and they take the car, everything, and leave. But one friend is calling me to Libya for many months. Say, let us assume I have gone to Libya. And now one person is giving a map to you saying, see, this is the map of Libya. You can use it whenever you want to go somewhere. The map has got very clear routes. For some destination, there are multiple paths. So you choose by your own which path you want according to what your brain says. You have control over the path. You take an accurate path selection by comparing the roads in the map, like OSPF. But there is another incident. I go there. He says, map, no map, sorry, we don't have map. But ಸೀದಾ ಹೋಗಿ ರೈಟ್ ತಗೊಳ್ಳಿ. இது லிபியா லாங்குவேஜ் நம்பிடாதீங்க, இது கன்னடா. நேரா போய் ரைட் எடுத்துக்குவோம். So we don't trust such people. What I mean is not in India. India you can trust. In Libya you cannot trust. Because when you take right, going straight and take right, there will be gunmen trying to kidnap you. So, see how dangerous RIP and EIGRP? Someone is directing the route. For me, one hop. For you, two hop. What if that is not a real one? What if that is a fake one? Someone has tuned it to give wrong info. That's why we cannot compare EIGRP with OSPF. We cannot compare EIGRP with OSPF and say EIGRP as a hybrid. Hybrid na enna OSPF மாதிரியும் இருக்கணும், RIP மாதிரியும் இருக்கணும். EIGRPக்கும் OSPFக்கும் சம்பந்தமே இல்லை. EIGRP 3 டேபிள் வச்சிருக்குதாமா. நெய்பர் டேபிள், டொபாலஜி டேபிள், ரவுட்டிங் டேபிள். OSPF 3 டேபிள் வச்சிருக்கு. அதனால என்னங்கிறாங்க, ஹைபிரிட் புரோட்டோகால் பத்தியா அப்படிங்கிறாங்க. நான் தப்பு, அது CCNA லெவல்ல வேணா அது பேசலாம். பட் CCNP வந்த பின்னாடி அந்த மாதிரிலாம் பேசக்கூடாது. We should not speak like that. OSPF is no way compared with RIP and EIGRP. RIP and EIGRP, they learn from neighbor. Neighbor தப்பா சொன்னானா இவனுக்கு அவ்வளவுதான், தப்பா தான் இவன் லேர்ன் பண்ணும். இவனுக்கா சுயமா போய் கண்டுபிடிக்கிறதுக்கு தெரியறதுக்கு வாய்ப்பு இல்லை. Whereas in OSPF, everyone is advertising their link status. That cannot be faked. So now, collecting the link state advertisement in a place called link state database, every router will know the complete map. After knowing the complete map, every router will position themselves in the map and find the best path to reach destinations. This is the reason why OSPF is called as Link State Routing Protocol. Now, we all know the administrative distance of OSPF, 110. That is the administrative distance of OSPF, 110. OSPF's administrative distance is 110. Yeah. So, keeping all this in mind, we are going to get into another class of OSPF lab and a few more theory also. With that, we'll conclude OSPF. All right. What you have learned today is the very good introduction to OSPF. Go through this Learn all these points. It is important for your interview. Do you have any question before we close?